Um, Hi. So I've got an upcoming project that I'm working on that require, of course, the furnace on. Well, so much for me narrating that video live. Voiceover it is then. Yeah, it figures that when I start recording, that's when my furnace kicks on. Anyway, as I was saying, I need a 486 system for an upcoming project I'm working on. And I don't want to use one of my PS2s because they're kind of rare and like special to me. So I need to just build a beater 486 PC just to do some testing with. And lucky me, I already got a motherboard for it. This one was given to me by a friend who I've known since grade school, basically. And that was like a couple years ago, but only now I'm just getting around to working on it. And he also gave me a sound card to go with it. I believe it's a Yamaha Edition 32, but that'll have to wait for another video. Meanwhile, the board comes with a 486SX25 already installed in it and 128 kilobytes of cache, and it has three VLB slots, which is nice. But one thing it doesn't have is any kind of identifying marking so I can tell what brand or model it is. All I know is it says version 1.0 by the keyboard connector, and I couldn't even find it on the retro web, surprisingly. But it was after a lot of Googling that I found out it was PC Chips M601. I think I found the model finally on Reddit, if I'm not mistaken. And of course, once I found the model number, turns out they did have it on the retro web, although it wasn't exactly the same revision as the one I had. But that's not a big deal. Anyways, the catch is that this one isn't working, and you can probably already see what the problem is. This trace right here got hot. Like, really hot. Hot enough to burn itself right off the board. And all that's left of it are these little dangly bits of the trace. So, obviously that power rail must have got shorted somehow. And that kind of made me think, before I go any further, I should check if there's anything else on this board that's shorted out. Okay, so I got it in continuity mode. Let's see if there's still any shorted pins. So the middle four should be black, or should be ground. So 5 volts. Yeah, that's just... going through capacitor. Ooh. No, that's... The resistance from the power rails to ground looks a little bit on the low side, but it's not a dead short. I'm thinking it's probably a capacitor charging up. Yeah, that could be a capacitor. Yeah, that's ground. That is that should be power good. 5 volts again. This is a plus 12, minus 12. I think this is the one that's broken. Minus 12 volt rail. So this is the broken one here. I'm not seeing any shorts between the other pins and the one that connects to the broken trace on the board. So maybe the short was on one of the expansion cards? So let's fix that trace and see where that gets us. And speaking of stuff to fix, this board has one of those rechargeable Varda CMOS batteries on it that us retro computer enthusiasts so dearly love. Yeah, not really. These things are known to lose their electrolyte and leak it all over the board, making all the traces under it corroded. But this one is actually in really good shape. I don't see any leaking or corrosion on it. So I'm going to leave it in place for now just for testing, and once we get the other issues solved, then I'll take it out. I wonder if it still has a charge. Not really. So you can see the broken trace runs from the AT power connector over to one of the expansion slots there on the right. And I could just run a bodge wire between those 2 points, but I want to try something else. So I watch a lot of Epictronics and Necroware and Bits and Bolts, and what they seem to do is scrape the solder mask off the trace and solder a piece of wire directly to the trace. It makes it look all nice and pretty, and it's probably a lot more durable too. And so I said to myself, If everybody else is doing it, why can't I? But it does make me a little nervous taking a Dremel to an old PCB. So before I did that, I wanted to see if I even needed to do it by testing the trace for conductivity, because it doesn't look like there's anything covering the copper, but actually there is. You just can't see it. And it conducts if I touch it right on the vias, but if I touch it on the trace itself, there's no conduction. So whatever's on there, I need to scrape it off. So I'm going to practice on a scrap piece of PCB that I have, because I feel like I'm going to mangle up the traces somehow. Before I pick up a totally good 486 motherboard, I want to do a test first, because I've seen people use these polishing tips to get the solder mask off traces and kind of reveal the copper underneath. But I don't know, it makes me a little bit uneasy. So I have this test board I made a long time ago that turned out was not going to be a workable design. So I don't care for anything about this board. So I'm going to test on this one. And just to be smart, I bought the cheapest Dremel available. So let's try this out. And this thing is, there's no variable speed control on this thing. It's just like on or off. And it's, yeah. Okay, let's try this. That doesn't feel too nice. But it seems to be working. Look at that, I'll be damned. It actually took it right off without seeming to harm anything else. Let's see if I can expose the copper pore. I'll wipe that off. Yeah, it makes a bit of a fine blue powdery mess, but well, that works a treat. Look at that. And on this side, there it goes. Okay. Now I feel better about doing it on the real thing. So, all right. It is time. Oh, you can actually be pretty accurate with this thing. I just need something to solder to. Wow, this will like peel right off if I'm not careful, so trim it as close as I can. Keep an angle here. Something solder on. Open that up. Yeah, I feel like it didn't get much on this side. Those are getting in the way. Gotta be careful here. Pat it clean. I think I got enough solder mask off there. Let's see if these are, see if they can conduct now. So if I just touch it to the trace. Yeah, okay. So that should be good then. So I got some pre-tinned copper wire. But first, I need to tin these traces. Okay, let's get some flux on here first. Oh, it's lifting right off. I can see it move. Okay, I'm not going to touch it anymore then. And this one, definitely not going to go all the way to the end. And get some more solder on there. Really got to come in from an angle here. It's not taking solder, is it? Okay, I guess I still need to clean that one off. Yeah, I couldn't get in there with the tool, but I can get in here with my tweezers. I can see that I didn't take it all off. So, but I can just scratch off what's left. And that'll have to do. I gotta get a memory card for this thing so I can actually record through it. But for now, yeah, now you're taking solder. Now, question is, how do I get this to stay in place? I think I'm going to do what I always do. So I'm going to use a little electrical tape. Will that hold it where I want it to? Perhaps. Can I get it on there at all? Just getting your iron on it. Getting it to stay in place. Oh, I think I got it. Forgot to put more flux on there. I'll hold it like that. Ooh, I got it stuck here. That's not good. Get it over. Yes, I can. Is this copper exposed? I probably should have did some grinding on that too. Yeah, because that's not taking solder. Oh well. Have to make that lie flat. Okay, so I think that's about the best I'm gonna be able to do, and it is on there. So I'll put one on the pad here, and I'll put one on a via here. Hey, that is a connection. Now that that's bridged back up, so do I have a short now? I believe that's just a capacitor. That's ground, that's ground, that's ground, that's ground. Connection there. Ground, 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 ground. And I think that's minus 12, plus 12, 5 volts, and that's the power good. If I put this on ohms, 11K. So I'm guessing there's some like resistors and capacitors to ground. Yeah, that one's charging up, so that must be a cap. That's in megs. Okay, so ultimately I think I'm gonna have to put something over this. I've seen there is liquid solder mask you can buy that will harden with UV light. I've seen some guys use nail polish. You could put Kapton tape over it, which I don't have. I'm gonna have to think about that one. Let's get that CPU out. Yes. And there it goes. In you go. And of course I don't have an AT power supply, so use an adapter. So I pulled this old power supply out of my stash, and I guess years ago I had written possibly bad on the side, but I think it still works. So I'm gonna just test it briefly with this power supply tester. Make sure all the rails are showing the right voltages. Is this still good? It definitely doesn't sound very good, but maybe I should try another one. Or maybe not. All the voltage readings on the power rails look pretty close. It's just got a bad fan bearing, so it sounds pretty bad. Okay, smoke test time, and go. Nothing's getting hot. Okay, so I need to find, well, I guess I should be testing all the voltages, not just 5. Not just 12 again. So 3 rows at C4, 3 rows up, 4 rows over. 1, 2, 3, 4. That should be 5 volts. And it is. And I don't think you get 12 volts to the CPU. 0 volts, which is good. 3, 4, 5, 6, 7, 8, 9. So that's a 5 volt. Why is that 5 volt? That should be 12. Right? There's the minus 12. Okay, so this must be pin 8. That's no wait state, which is active low. And there's my 12 volts, 12.5. I get minus 11.93, so I have good power rails. That's good. Clock is C3, and if I zoom in, looks like PC chips were nice enough to actually label the pen grid for me. So if I connect put A, B, C, 1, 2, 3. Okay, so it got me a little piece of wire here. So I can go like that. I can probably just put it straight into the black wire on the power connector. Like so. Now I should be able to read this on the scope. I hope. Hey, 25 megahertz. I have a clock signal. Okay, so I got it hooked up to a post analyzer card now, so I can see if there's any codes. I'm not expecting too much since there's no RAM in it yet, but I'm curious. Let's see what happens. Okay, so no codes, which makes sense, but what concerns me is that the only power rail I'm seeing is the 12 volts, which is the one I fixed. But I'm not getting 5 or minus 12. But I was getting them with the multimeter. That doesn't make sense. They have to be there. CPU is still totally cold to the touch. I guess I gotta put some RAM in it? I don't know how that solves my voltage issue. Oh, it did something. Okay, now I have 5 volts. CPU's not getting hot. It's still cold. Okay, I just want to try one thing here. Let's see if I can manually send a reset on it. I'm going to jump the pins. Doesn't really do much. So let's try putting some RAM in it. Unfortunately, the only 30-pin sims I have are these, which came with a motherboard that's seen better days, and it's probably going to be a future project on this channel. So it looks like it's been exposed to moisture, and there was some rust on it, but the sims themselves look okay. You can see this. I don't know why they put tape over here. It's kind of crusty. I'll have to work on getting that off, but the contacts look all right. And I cleaned them up with a little bit of rubbing alcohol. So hopefully, if I'm lucky, they'll work. Okay, so I got the manual printed out, and I can see the pattern here. No matter what quantity of RAM you got, you're supposed to populate the entire first bank before you populate the second bank. In any case, it looks like you have to have all 4 in there. Actually, you know what? This is bank 0. I have to populate this 4 first. Like that. And then you tilt it up forward. And it locks in like that. And I hope these things work. Okay, in and up. And there it is. So that is bank 0. Here we go. Not looking great. Oh, I got 5 volts now. No postcodes though. No beeps. I wonder if the slot matters. It's not looking great. Okay, I just thought of something else for a second. I didn't try clearing the CMOS. So one of the annoying things about this is this board is a Rev 1. Well, my data sheet is for Rev 1.3 or version 1.3, and the jumpers on this revision, they don't match the positions of the jumpers on this board, and the numbers don't match up either. So I don't really know which jumper I'm changing. But at least for jumper 1, which is the clear CMOS. They both seem to agree on that. So for the CMOS memory clear feature, I need to jump pins 3 and 4. Come on. I take that out of there. And I jump 3 and 4. And it looks pretty much like it did before. And I'll turn it off. And so it says CMOS normal operation internal, which I'm guessing means this is the CMOS battery. But you can also use an external CMOS battery, which is good, which I plan to do. There. Does that make a difference? Of course not. And I would check the settings of the other jumpers too, if I knew what they were. Okay, well, it turns out RetroWeb does have it. And it even has a manual with the correct jumpers. So I took about 15 minutes to go through all the settings and compare them to what's on the board right now. And I noticed 2 things. So JP4, that is JP4. That jumper is open, which selects 3.45 volts, which is surprising because I don't see a voltage regulator anywhere on this board. But it turns out that there is a special voltage regulator board that you can get, which plugs into J10 here. And looks like they filled one of them in with solder, presumably so to keep you from plugging it in backwards. But this needs to be closed to select 5 volt operation, which kind of doesn't make sense because I measured 5 volts on the CPU, but maybe that's only for certain pins. I think the 46 has different pins for I/O and for internal voltage, so that one out of there. And close that jumper. Let's see if it blows up or not. Well, that sucks. Okay, so I was up till like 2 in the morning the day before yesterday working on this stupid thing. And you know what they say, that if there's something that's if you're completely stumped, then it must be something stupid. I had the card in backwards. Me. So we got our voltage rails. Unfortunately, no signs of life out of this thing. Got voltage rails, got clock. Nothing doing. Alright, so this video is already longer than I would like it to be, so I think what we'll do is we'll make it a 2-parter. I'll have to make a follow-up video on this one. I'm still not ready to throw in the towel yet. I've already done some more troubleshooting on it. But that's it for this one. Join me in the next one, and who knows, maybe I'll actually fix something for once. Anyways, thanks for watching, and I'll catch you on the next one.
How first?